So today let's see question of intersection of a plane and a cone. So in the question it says that this plane cuts this cone in a perpendicular generator, and we are supposed to prove this relation, that the plane cuts cone in perpendicular generator if this relation is satisfied. So the question says that the plane ux plus vy plus wz equals to 0 cuts cone, that is ax square plus by square plus cz square equals to 0 in perpendicular generators. So let equation of generator be x minus alpha upon L equals to y minus beta upon m equals to z minus gamma upon n. So let this be my equation of any generator of the cone. Further, if you observe that the given equation of cone, that is this, is homogeneous, and we can easily find out vertex of cone using del f by del x equals to 0, del f by del y equals to 0, and del f by del z equals to 0. So if I do so, I'll get 2ax equals to 0. From here I got my x equals to 0. Likewise, from second partial differential equation, I'll get 2by equals to 0, which gives me y as 0, and the third one gives me 2cz equals to 0, from which I'll get my z equals to 0. So basically vertex of the given cone is 0, 0, 0. So if this is the vertex of cone, then generator line must also be passing via vertex of cone. So my generator line reduces to x by L equals to y by m equals to z by n. So if this is my generator line, I can easily find out any arbitrary point on generator line. So that will be arbitrary point on generator line. So that is basically LR, MR, NR. I got that by equating the generator line with some constant R. So this is any arbitrary point on generator line. So if this is any arbitrary point on generator line, then this point must satisfy equation of both plane and cone, because plane is the one that is intersecting cone in perpendicular generator line. So if this point must satisfy equation of both plane and cone. So using that, I got u into LR plus v into MR plus w into NR equals to 0. So that basically gives me UL plus VM plus WN equals to 0. Let's name it this equation as star 1. Likewise, this point must satisfy equation of given cone also. So using that, I'll get A into LR square plus B into MR square plus C into NR square is equals to 0. So if I simplify this equation as well, I will get AL square plus BM square plus CN square equals to 0, and let's name this equation as star 2. So using the above condition, I got two equations in L, M and N, and I can easily solve these two equations to get values of L, M and N. So we can just eliminate, write one of the direction cosine in terms of other two. So if I do that using UL plus VM plus WN equals to 0, so I got my L as minus of Vm plus Wn upon u. Now what I can do is I can just substitute value of this L in star 2, and that will give me basically a quadratic equation in M and N. So on doing that, I got A into Vm plus Wn upon u whole square plus B into M square plus C into N square equals to 0. So if I simplify it, I get A into Vm plus Wn square plus Bu square M square plus Cu square N square equals to 0. So from here what I can do is I can club in coefficients of m square, n square and m and n. So if I do so, I'll get coefficient of m square as ab square plus bu square into m square plus a w square plus cu square into n square plus 2mn into avw equals to 0. And now what I can do is I can divide this whole term with n square. So if I divide whole term with n square, I'll get av square plus bu square into m by n square plus 2m by n into avw plus aw square plus cu square equals to 0. So if you see that this equation is quadratic in m by n. So if it is quadratic in m by n, then I can easily find out product of its quadratic roots and also the sum of its quadratic roots. I got if this ax square plus bx plus c equals to 0 is my quadratic equation and x1 comma x2 is its root, then x1 dot product of its root is basically c upon a. So using this result, I'll get my m1 upon n1 into m2 upon n2 as aw square plus cu square upon av square plus bu square. So this is basically product of my roots. So if I simplify it, I will get m1 m2 upon aw square plus cu square equals to n1 n2 upon av square plus bu square. So likewise what I can do is I can now substitute any other direction cosine other than L from the star 1 in star 2 and get L1 product of L1 into L2. So if you want to solve, you can solve that as well, or you can just observe the pattern that the m1 into m2 and n1 into n2 has followed. So if you observe star 1 and star 2, you will see that my direction cosine of m1 into m2 is basically a into w square plus c into u square. Likewise, if you observe direction cosine of n1 into n2, that is basically a into v square plus b into u square. So using the same pattern, I'll get my L1 L2 as c into v square plus b into w square. So from here I got values of all L1 L2 m1 m2 n1 n2, and I can just equate it with k to get the actual direction cosine. That will be basically L1 into L2 is k into c u v square plus b w square, and m1 m2 as k into a v square plus b u square, and n1 n2 as k into I get my m1 m2 as aw square plus cu square, and n1 n2 as av square plus bu square. And we know that if so the question says that plane cuts the cone in perpendicular generator, and we know that two lines cut each other in perpendicular generator if L1 L2 plus m1 m2 plus n1 n2 equals to 0, where L1 m1 n1 n2 have usual meanings. So if I put values of L1 L2 m1 m2 and n1 n2 in this equation, what I'll get is k into cv square plus bw square plus k into aw square plus cu square plus k into av square plus bu square equals to 0. So if I simplify it by clubbing coefficients of u square, v square and w square, I'll get u square into c plus b plus v square into c plus a plus w square into a plus b equals to 0, and which is basically my required condition when the given plane cuts the cone in perpendicular generators. So this is what we are supposed to prove. So let's move on to next question. So let's see this question. So in this question we are supposed to show that the plane which cuts this cone in perpendicular generator touch this cone as well. So they have given us two cones. Let's name them as C1, which is the original cone, ax square plus by square plus cz square equals to 0, and C2 the second cone, that is basically x square upon b plus c plus y square upon c plus a plus z square upon a plus b equals to 0. So first we'll look on cone 1 and then we'll see the conditions related to cone 2. So the cone 1 is ax square plus by square plus cz square equals to 0. So if you observe that, like we did in previous question as well, the vertex of this cone will be basically 0, 0, 0. Also, we are supposed to show that the plane which cut this cone in perpendicular generator will touch the second cone. So first let us find out the equation of cone and the condition related to that, such that the plane cuts this cone in perpendicular generator. So equation of any tangent plane to, let's say, 1. So equation of any plane to 1 will be basically ux plus vy plus wz equals to 0, where u, v and w are basically the direction cosines of that tangent. So, and this also passes through origin. So we'll get our equation of generator line as x minus 0 upon L equals to y minus 0 upon m equals to z minus 0 upon n, because 0, 0, 0 is my vertex of the cone. So this is basically the generator line which generates the equation 1. So if you observe that, this leads us to the previous question only. So if you'll solve this to get value condition when this plane cuts the given cone in perpendicular generator, so that will be basically u square into b plus c plus b square into a plus c plus w square into a plus b equals to 0. So in exam you're supposed to solve this condition like we did in previous question, like this, but since we have done this in previous question, I'm using that as a result here directly. Also, I got this equation of plane as, because equation of any tangent plane to the given cone will be basically a x1x plus b y1y plus c z1z equals to 0. So what I have done is I have assumed ax1 as u, by1 as v and cz1 as w, just to simplify the process. So this will be basically tangent plane at any arbitrary point x1, y1, z1. So this is basically my condition when the plane ux plus vy plus wz will cut the cone in cone 1 in perpendicular generator. And now we are supposed to show that this plane, now we are supposed to show that our claim is that plane ux plus vy plus wz equals to 0 touch the second cone, that is basically x square upon b plus c plus y square upon c plus a plus z square upon a plus b equals to 0. So there are two methods to go ahead with this. So one is basically if this plane touches this cone, so you can use the if this plane touches this cone, then this will be basically tangent to the cone. So you can use that tangency relation which says that any plane is tangent to given conicoid if it satisfies L square upon 1 upon b plus c plus m square upon 1 upon c plus a plus n square upon 1 upon a plus b equals to 0. And from here I'll get L square into b plus c plus m square into c plus a plus n square into a plus b equals to 0. And I can eliminate L, M and N using the generator line condition. So I'll get it as x square into b plus c plus y square into c plus a plus z square into a plus b equals to 0, which is the same condition which we got for perpendicular generators. So you can either do this, or what you can do is you can basically find the reciprocal cone of this and you'll get this only. So we find reciprocal cone by because our plane is ux plus vy plus wz equals to 0. So direction cosines to normal are basically u, v and w. And this plane will touch the given, if this plane touches the given cone, then the relation will be a u square plus b v square plus c w square plus 2 f v w plus 2g u w plus 2h u v equals to 0. And you can just find a, b, c, f and g using the cone itself. So my a is basically bc minus f square and b is my ca minus g square and c is minus my ab minus h square. Likewise my capital F is gh minus af and similarly capital G and capital H. So you can use this as well and you will get this condition only if you solve this. So this is our second question. So let's move on to next question. So the next question says that find the equation of straight line in which this plane cuts this cone. Okay, also find the angle between two straight lines. So if you observe the given cone, so the given cone is basically 4x square minus y square plus 3z square equals to 0. It's already in homogeneous form, and if you find out its vertex will be basically 0, 0, 0. Like we have seen in previous question, it is of form ax square plus by square plus cz square equals to 0. And here a is my 4b minus 1 and c is 3. So if you find its vertex will be basically this. So we are supposed to find the equation of straight line in which the plane 2x plus y minus z equals to 0 cuts the cone. So since my line will be passing via vertex as well, so equation of any arbitrary line will be x minus 0 by L, y minus 0 by m and equals to z minus 0 by n equals to r. And I can find out any arbitrary point on this line, that will be basically LR, MR and NR. So this arbitrary point must be satisfying both equation of plane and equation of cone. So if it satisfies both, I'll get 4 into LR square minus MR square plus 3 into NR square equals to 0. So if I simplify it, I'll get 4L square minus M square plus 3N square equals to 0, and it also satisfies equation of plane. So by that I'll get 2 into LR plus MR minus NR equals to 0, and if I simplify it, I'll get 2L plus M minus N equals to 0. Let's name it as star 2. So now I got two equations in L, M and N, and I just need to simplify them to get values of L, M and N. So that will be basically, what I can do is I can take N and then solve it for L, M and N. So from here my N is 2L plus M. So if I just substitute this value of N in star 1, I'll get 4L square minus M square plus 3 into 2L plus M whole square equals to 0. Now I can just club in coefficients of L square, M square together. I'll get 4 plus 3 into 4L square plus minus 1 plus 3 into m square plus 4 is 12lm equals to 0. That is basically 16l square plus 2m square plus 12lm equals to 0, which is equals to 8l square plus m square plus 6lm equals to 0. And I can write it as 8l square plus 4lm plus 2lm plus m square equals to 0. And if I take 4l as common, I'll get 2l plus m. Likewise, from last two term, if I take m as common, so I'll get 2l plus m equals to 0. So from here I got 2l plus m into 4l plus m equals to 0. So from here I got two relations in between l and m. So I'll get either 2l plus m will be equals to 0 or 4l plus m equals to 0. So from here I'll get basically direction cosines of two generator lines. So case 1 is when 2l plus m equals to 0. So from here I got my m as minus 2l and my n is basically 2l plus m. So from here I got my n as 2l minus 2l equals to 0. So my n is 0. So direction cosine of any line will be L by 1 equals to m by minus 2 equals to n by 0. And my case 2 is when 4l plus m equals to 0. So from here I got my m as minus 4l. So if I solve it for n, which is basically 2l plus m, so I got my n as minus 2l. So from here I got l upon 1 equals to m upon minus 4 equals to n upon minus 2. So these are basically my two generator lines which we get when this plane cuts the cone. So we are supposed to find the equation of straight lines. So the two straight lines are x by 1 equals to y by minus 2 equals to z by 0, and x by 1 equals to y by minus 4 equals to z by minus 2. I got this because my two straight lines will also be passing via vertex from here. Now we are supposed to find the angle between two straight lines. So my angle between two straight lines will be basically L1 L2 plus M1 M2 plus N1 N2 divided by under root L1 square plus M1 square plus N1 square and L2 square plus M2 square plus N2 square. So from here I got cos theta as 1 plus 4 2s are 8 divided by under root 1 plus 4, 1 plus 4 4 is 16 plus 4, which is basically 9 upon under root 5 into under root 21, which is basically 9 upon under root 105. So this is basically my angle. So my theta is basically cos inverse 9 upon under root 105. This is my angle between two generator lines. So let's move on to next question. So the next question says that examine whether this plane cuts the cone in perpendicular lines. Okay. So this question is also basically similar to the previous questions we did. So they have given us equation of a plane which is basically x plus y plus z equals to 0, and equation of cone is basically yz plus zx plus xy equals to 0, and we are supposed to examine whether the plane cuts the cone in perpendicular lines. So if you observe this cone, so from here we'll get our vertex as 0, 0, 0. You can check it by equating del f by del x equals to 0, del f by del y equals to 0, and del f by del z equals to 0. So you'll get three conditions: x plus y, y plus z equals to 0, x plus z equals to 0, and x plus y equals to 0. If you will solve these three conditions, you'll get x equals to y equals to z equals to 0. So our 0 comma 0 comma 0 is basically the vertex. So the equation of any generator line will be basically x minus 0 upon L, y minus 0 upon n equals to z minus 0 upon n. So from here I'll get any arbitrary point on generator line that will be basically LR, MR and NR, and this point must satisfy the equation of both a plane and the cone, because plane is cutting the cone. Then only we got our generator line. So that will be basically L plus M plus N equals to 0, and another will be Lm plus Mn plus Ln equals to 0. So I got two equations in Lm and N, and I can easily solve these to get a value of Lm and N. So from here, if I take my L as minus of M plus N and substitute it in second equation, I'll get M into minus M minus N plus Mn plus N into minus M minus N equals to 0, and simplify it, I will get minus M square minus Mn plus Mn minus Mn minus N square equals to 0. So on simplifying it, I'll get M square plus N square plus Mn equals to 0, and it will be basically M by N square plus M by N plus 1 equals to 0. So it is a quadratic equation in basically M by N, and we are supposed to check whether the plane cuts the cone in perpendicular lines. So the plane will cut the cone in perpendicular line if it satisfies relation summation L1 L2 equals to 0. So from here will basically calculate the product of the roots. So that is basically L1 by N1 into M2 by N2, which is basically 1 upon 1, which is 1 only. So from here we got M1 M2 upon 1 equals to N1 N2 upon 1. Likewise, we can solve for another direction cosine as well. Like now we can equate n equals to minus of L and minus of n, and then substitute it here in second equation, and from that as well we'll get our L1 L2 as 1 only. So for the plane to cut the cone in perpendicular generators, L1 plus L2 plus M1 plus M2 plus N1 plus N2 must be equals to 0, but we got our L1 L2 plus M1 N2 plus 1 N1 N2 as is equals to 3. Of L1 L2, which is basically equals to 3 of M1 M2, which is also equals to 3 of N1 N2. So basically only those lines will be in perpendicular, will act as perpendicular generators which are there in the either of the three planes, that is basically XY plane or YZ plane or ZX plane, because then only we'll satisfy our relation L1 plus M1 plus N1 plus N1 into N2 equals to 0. So the lines which are lying in these planes will only be the only lines that will satisfy that relation. So let's move on to next question. So in next question we are supposed to prove that this plane will cut this cone in perpendicular lines if this is satisfied. So the given plane is AX plus BY plus CZ equals to 0, and given equation of cone is YZ plus ZX plus XY equals to 0. So the vertex of cone will be 0, 0, 0 as we have seen in the previous question. So equation of any generator line will be basically x minus 0 upon L, y minus 0 upon L, z minus 0 upon n, where basically L, M and N are direction cosines of the line. So any arbitrary point on generator line will be LR, MR and NR. And this arbitrary point must satisfy the equation of both plane and the given cone. So if that's the case, I'll get AL plus BM plus CN equals to 0 and LM plus MN plus LN equals to 0. So I got basically two relations in L, M and N, and I can easily solve it to get values of L, M and N. So if I calculate value of L from the first equation, I'll get minus of BM plus CN by A. Now I can just substitute it in other equation to get a quadratic equation in M and N. So I'll get M plus N into minus of Bm plus Cn by A plus Mn equals to 0. So if I simplify it, I'll get minus of M plus N into Bm plus Cn plus Amn equals to 0. So I can simplify it to get minus Bm square minus Bmn minus Cmn minus Cn square plus Amn equals to 0. So if I just club in all the coefficients of similar variables together, I'll get Bm square plus Cn square plus B plus C minus Amn equals to 0. I can divide the whole equation by n square to get a quadratic equation in M by N, which is basically B plus C minus M by N plus C equals to 0. So this is my quadratic equation in M by N. So if I solve it for product of roots, I'll get M1 by N1 into M2 by N2 as C upon B, which is basically equals to, from here I'll get my M1 into M2 as 1 by B equals to N1 into N2 as 1 by C. I didn't take it like M1 by M2 by C and N1 by N2 by B because we're supposed to prove our relation, this as our relation, and here I need 1 by A plus 1 by B 1 by C. So what I have done is I have written this as equals to 1 by B divided by 1 by C and then exchange the terms. So likewise, if I can also get for L1 by L2 and N1 by N2 as, if I substitute this equation of M, if I substitute this equation of M in this previous equation, I'll get L1 by L2 and N1 by N2 as C upon A. So from here I'll get L1 by L2 upon 1 by A equals to N1 by N2 upon 1 by C. So from here L1 by L2 upon 1 by A is equals to M1 by M2 upon 1 by B, which is equals to N1 by N2 upon 1 by C. And if I equate it with K, I'll get L1 L2 as K by A, M1 M2 as K by B and N1 N2 as K by C. And we know that the two lines cut in perpendicular generator if L1 plus L2 plus M1 M2 plus N1 N2 is equals to 0. So if I equate it with 0, I'll get K by A plus K by B plus K by C equals to 0. And K is my any arbitrary constant, so I can just get rid of that. So from here I'll get my relation as 1 by A plus 1 by B plus 1 by C equals to 0. So basically this is my relation when the plane cuts the cone in perpendicular lines. So let's move on to next question. So the next question says that find the equation to the lines in which this plane cuts this cone. So this is basically a repeated question. We have done this previously. So in this question you can find out the vertex which will be 0, 0, and you can assume any generator line as x minus 0 by l equals to y minus 0 by n equals to z minus 0 by n, and you can just find out any arbitrary point which will be satisfying equation of both plane and the cone, and then you can just solve for l, m and n, and you'll get equation of the lines which lies on the plane and cuts the cone. So let's move on to see next question. So the next question is, show that this cones cut the sphere in two equal circles and find the area. So the given equation of cone is yz plus zx plus xy equals to 0, and the equation of sphere is x square plus y square plus z square equals to a square. So we're supposed to show that the cone cuts the sphere in two circles. So what we can do is we can write equation of sphere as x square plus y square plus z square plus 2 into xy plus yz plus zx equals to a square, because this term is equals to 0 from the equation of the cone that is given to us. So if we just simplify this, observe the left hand side, which is basically equals to x plus y plus z square equals to a square. So if I solve this, I'll get x plus y plus z equals to plus minus a. So this is basically my equation of plane wherein the given cone cuts the sphere in two equal circles. These are the basically two planes which cut the given sphere into two circles. So the equation of circles are represented by equation, or circles are basically x square plus y square plus z square equals to a square, comma x plus y plus z equals to a, and equation of another circle is x square plus y square plus z square equals to a square, comma x plus y plus z equals to minus a. So we are supposed to show that the cone cuts the sphere in two equal circles. Okay, so if you observe the by observation only, it's evident that the two circles are basically equal. Basically, if let's say this is my sphere and let's say this is origin, so one circle lies in the positive coordinate and another lies in negative coordinate. So, and that is basically evident because the two lines of plane are basically parallel to each other, and the distance from origin is basically one in positive direction and other in negative direction. Further in the question, they have asked us to find the area. Okay, so let's say if this is my circle, and you can observe that the center of, let's say this is my sphere, so you can observe that center of sphere is basically 0, 0, 0, and radius is a, and let's say this is my equation of plane. So, and if I join O, P and M, if I draw any perpendicular from O to the equation of plane, so the foot of perpendicular will be, let's say it is M, and let's join O and P, and O and P is basically representing the radius of sphere. So OP is basically A. So let us find out this OM. So OM is basically distance from 0, 0, 0 to plane x plus y plus z equals to minus a. So my OM is basically equals to 0 plus 0 plus 0 plus a divided by under root 1 plus 1 plus 1. So I got my OM as basically a upon under root 3. Let's write it in mode, because if we find distance from both the planes, it will be plus minus a. So my OM is likewise from, we can draw it here also, it will be OM dash. So we are solving it from bottom plane. So I got my OM as mod A by root 3. So I can use Pythagoras theorem on OPM. So if I use that, I'll get OP square equals to OM square plus MP square. And I already know that OP is basically my radius of square, which is A square, and my OM is mod A by under root 3 square. So from here I'll get MP square, and my MP is basically the radius of circle, which we get by intersection of cone and sphere. So my MP is A square minus A square by 3 under root, which is basically under root 2 by 3a. So I got my radius of the circle, which we get as under root 2 by 3a. So area of circle is pi r square, and my r is basically MP. So I got my radius as pi 2a square by 3. So my area is 2 pi a square by 3 unit square. So this is basically my area of the circle, in which we got by intersection of cone and plane. So these are the only questions that are asked for intersection of plane and the cone. So thank you for watching.